Example number 3, solving an equation with one radical. So this equation has one radical like the first one did, but this radical has other stuff going on underneath it. And this one's raised to a cube root instead of just a square root. So again, we have to follow the same steps we've been following. We have to get that radical to be isolated. So we have to get it to be all by itself. So the first thing I'm going to do is add the 5. So let's add 5 to both sides. On the left-hand side, that leaves us the cube root of 8x plus 3. And negative 5 plus 5 is 0, so those are gone. And on the right-hand side, we have negative 2 plus 5, which we know is 3. Okay, so now we have to get the stuff that's underneath the radical to come outside the radical, so we're going to use inverse operations to do that. And the opposite of being the cube root of something is to cube it. So I'm going to take both sides of this and I'm going to cube it. What we do to one side, we've got to do to the other. Now, the cube root and the cubed cancel each other out. So on the left, I'm left with 8x plus 3. And over here, I have 3 to the third. 3 times 3 is 9, times 3 is 27. And now we just get to solve for x. So subtract 3 from both sides. 8x equals 27 minus 3 is 24. And divide both sides by 8. 24 divided by 8 is 3. Okay, so I think my answer is 3. I'm going to do a quick check just to make sure it works. So I'm going to come over here and check that the cube root of 8 times 3 plus 3 minus 5 really does equal negative 2. So underneath the cube root, I've got 24 plus 3, which is 27, minus 5 equals negative 2. Cube root of 27 is 3, minus 5. That does equal negative 2. So this one checks, and we're good to go. The solution is x equals 3. All right, there are some examples. Again, I want you guys to try these on your own, and that way you can check and see that you're doing them correctly and that you don't have any questions. The solutions to these worked out are on the next slide.